Okay, I'm hoping this is working. So, predicting acid-base reactions. A lot of this is going to feel very similar to part of Unit 2. So that's great. So it's going to feel a little bit like review, and it's nothing you have to like learn another steps to do. It's kind of the same thing. So if you can see it as a similarity, then it feels more natural to you, and then it's easier for you to do. So the first thing you're going to do, just like we did with the chapter 12 stuff, is we're going to identify all the entities that are present in the solution, the molecules, the atoms, and the ions. Sorry, I probably should have said, hold on. When you have an acid-base reaction happening in your flask, it's probably an aqueous solution, right? And therefore, you know that water can accept and donate a proton. So actually, when you're reacting an acid and base, you have 2 acids and 2 bases present in your solution. You have, let's say, hydrochloric acid, hydrochloric acid, for example, you've got hydrochloric acid on there, in there, sodium hydroxide, and water. So the question is, who is going to donate the proton? Who is going to accept the proton? Now, you already know, hopefully, that these are going to be the pair that match up. And these are going to add together, and that's going to transfer proton over to the OH, and you're going to get HOH and NaCl. So you know that water doesn't really participate in that. But when you start doing the weaker acids and the weaker bases, it's not always so obvious. And so sometimes water is your strongest acid in there, and it will react instead of your HCl or whatever. And that's what these steps are trying to determine. When I chuck the things in my beaker, which 2 actually react together? In an easy situation like that, that's fine. Do you know why? Because this is a super strong acid, and this is a super strong base. And just like we did for a redox reaction, the strongest reducing agent and the strongest oxidizing agent reacted, same thing here. The strongest acid and the strongest base are going to react. And the others just hang out and watch, because they're not strong enough. Did you get it? Okay, so what we're doing is, the first thing you need to do is list the entities, just like we did with the other one. You dissociate ionic compounds, just like we did with the other one. Do you remember that? And I did a whole thing about, in Chem 20, you were supposed to learn this. Do you remember me saying that? And I'm still saying it. Okay. So ionic compounds and bases dissociate. Weak acids. Now this is something that you sort of might have seen a little bit of in Unit 2. And I said, look, if you're not sure if it dissociates or not, look for both things. Look for it together and look for it separate, right? Well, now that we've done organic and you remember weak acids a little bit more, you should be able to figure out whether you're supposed to keep them together or not now. So weak acids, you're going to write the complete molecule. So you do not break it up. So, for example, H2SCO3 is written as H2CO3, not H plus and HCO3 minus. So if it's a weak acid, you keep it together. Why? Because of that box I just showed you. 99% of it doesn't dissociate. That little picture that we had of those little circles. 99% of it was together. There's just a teeny, teeny, tiny bit of this. Not enough for it to matter. Okay? If it's a strong acid, we write H3O plus. H3O plus now. No longer just H plus.
Junior class change.
Okay? Why? Because it's H3O plus in your data booklet table. Then Craig will be looking for H plus until he's in the state. Okay? Or golfing, whatever comes first. And for polyprotic, like H2SO4, you're going to write your H3O plus, not your SO4 2 minus. You're going to write HSO4 minus, because you only give up 1 proton at a time. Okay? You okay with that? You only give up one proton at a time. And then you don't dissociate that because it's a weak acid. Remember, we keep weak acids together. And then you're going to label each entity, each thing you've listed, as an acid or a base. Okay? And then you write the reaction with the strongest acid and the strongest base reacting. Everybody okay with that? I know it was a whirlwind tour. Top tips for me. Number 1, write your acids when you're writing, just like we did strongest reducing agent, strongest oxidizing agent. We're going to write our acids at the top of that list and the bases at the bottom of that list, so it's easier to piece them together and figure out which two go together. And you include water for all aqueous solutions, just like we did for Unit 2. As soon as you see aqueous or solution, we write water in our list. Okay, so for example, here's an example. H2CO3 reacts with that. What are my species present? Let's have a look at this one. What do I write this as for my species present? Nope. Oh, yeah. Is it weak or strong? Good question. Okay, so I forgot to tell you this bit. This is a good spot to tell you. Page 8 and 9 of the data booklet. It is a weak acid. Page 8 and 9 of the data booklet. Do you see the ones at the top that say very large and 1? Their K value is greater than 1. Do you remember that whole thing about the top being bigger than the bottom? So that means their products are greater than the reactants, which means if you're looking at this, these products are greater than those reactants if your K value is greater than 1. So that means you made more of this than you have of that. Get it? So K is a, did you get that wrong on your quiz? What quiz? That's even worse. Got it? No. Okay, that face you made, I thought you were thinking you did that wrong. Okay, so if it has a very large K value, that means it is a strong acid. Okay, so strong acids then are perchloric acid, hydrochloric acid, hydrochromic acid, hydrochloric acid, oh that was hydroiodic acid from before, sulfuric acid, nitric acid, and H3O+. Get it? Go? Okay, so is this a strong or weak acid? Weak, because it's not one of those. So it must be down below.
So if it's below where it says very large, then it's
A weak acid. But you don't,
like most of these are weak acids.
right, but you don't need to find it. Okay, don't waste your time finding it. If it's not in the top list, it's not strong. So what do we write down for our identity? Or our entity, I mean, sorry? H2CO3. So, short version, Craig, put your phone away. Short version, weak acid, so it stays together. Aqueous, what else do I list? H2O. NaCN, what do I list? Na plus and Cn minus. Why? Because it dissociates. Why? Because an ionic compound. Okay? Okay, so now, is this going to be, this is all the work you're going to do before you look it up. Is this going to be, pardon me, let me ask this question, it's probably a faster question. Oh no, maybe not. Is this an acid or base? Can it be a base?
Yes. No.
No. Could we form H3CO3 plus? No, not really. H2O. Acid and a base. Yeah? Yeah. Na plus.
Either. Either.
Can you accept a proton
Yeah.
and become NaH2 plus? No. Can it donate a proton? No. So it's going to be, what do we call that? Spectator. ion. How mmany times has Na plus been a spectator ion? Like a million times. Okay. Cn minus, it's a base. It can accept a proton and become HCl. Okay? Now you know where to look for them. Sort of. You know, ish. You know whether you're looking on the left or right column, not the whole thing. So find your H2CO3 and compare it to where water is on the table. Remember, water's both. Actually, it's a good exercise. Find water on both sides so you know where it is, you memorize where it is approximately so you can go there quickly. So in your data booklets, find where water is. It's shaded. Oh, easy now. Well, that's good. That's lucky. Okay, so water is shaded, and find your H2CO3 and tell me which is the stronger acid, H2CO3 or water. Okay, so it's a stronger acid. Which is the stronger base, water or Cn minus?
No. Cn minus.
Cn minus is further down on the left-hand side. Wait, what? Right-hand side. Cn minus, is Cn minus further down than water? On the title says conjugate base.
Yes.
No.
Cn minus.
Yeah.
Yes. Yes. Yes.
It should be. Somebody help Raj out there. Cn minus is at 6.2 and water is all the way up at 1.
Okay.
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 Okay. Can you look? Raj, don't just take my word for it. You need to know how to do that on your own. I think you're looking for water on the other side. It has to be on this side of the table. Don't look for water over here. Just like when we were looking for reducing agents, we only looked at one side of that arrow. Got it? Okay. So here's your strongest base, here's your strongest acid, and now those are the two things that are reacting. So we put H2CO3 and Cn minus, and we transfer a proton. So where the proton's going to go from the acid to the base. Everybody okay with that? So we end up with HCN and
Wait, wouldn't this Cn just be neutral? It is. It's just H3.
sorry, that
Oh,
plus
oh.
is like between them.
Sorry.
No, it's okay. HCN and HCO3 minus.
So fully.
Okay, so I only transfer one proton. Can you do that on your own? Like, can you see that without having to look? However, if you can't see that, Raj, if you can't see it, look how this, Raj, this, which you've already found in the data booklet, is paired with this on the other side of the column. So in your data booklet, you have H2CO3 and HCO3 minus. See that? So if you can't I prefer you to see that the protons transfer so that you can answer the question about the XYQ acid base, right? But if you can't see the proton transferred, they are here for you. Easy. And so here's one. And what's this called? This is the acid and this is the base. This is the conjugate base and this is the conjugate acid. Can the conjugate acid act like an acid?
Yes.
Yes, that's why it's called a conjugate acid. Okay? Yes, Emily.
So are if it's just an element by itself, are they usually spectator ions?
That's not an element by itself.
Oh,
That's
an
an
ion.
ion. And I wouldn't say that because like Cl minus can accept an H. So it's a base.
Okay.
But I would say that for all positive ions, all cations, yes. Okay, so in your textbook on page 690 are some practice problems, which should help you do those steps. And here clearly the photocopying has chopped it off. I wanted you to identify, I wanted you to define polyprotic and polybasic. So two things to do, number one that, and number two that.